Alright, so we are going to try out some rational inequalities here. Now what we're going to do is we're going to start with some simpler, more fundamental rational inequalities like number 1 here, and then we are going to move on to some more complex ones that you'll see closer to the bottom of the page. So here's the thing, you always want your rational inequalities to do two things. You want one, they need to be quote-unquote equal to 0, right? Obviously not equal because it's an inequality, but you need to have 0 on one side of the equation. You need to have your fraction, your rational expression, whatever it may be. It needs to be it needs to have 0 on the other side. That's key. The second thing is it needs to be in simplest form. Simplest form, of course, like number 1 here, x minus 7, x minus 1. That's as simple as it gets. Same with number 5, x plus 3, x plus 5, x plus 2. We are in simplest binomial form. Something like number 6 is not. It may be, quote-unquote, equal to 0, but it has a polynomial down there, and polynomials are never in simplest form, binomials are. But we're going to start with one here that's already equal to 0 and already in simplest form with number 1. So what you want to do, this is kind of like the polynomial inequalities one. This is kind of an extension upon that. You want to set each of the numerator and the denominator equal to 0. You actually want to set each individual part of this equal to 0. So in this case, we want x minus 7 equals 0. And then we want x minus 1 equals 0. And I know I'm not using those inequalities, but in all reality, with most inequality problems, you are not going to actually utilize that inequality until the very last step. You can kind of ignore it for the majority of the time. So of course here with x minus 7 being equal to 0, we find out x is 7. And with x minus 1 being equal to 0, we find out x is 1. So we're going to do the same thing as before, and we're just going to make a number line here. And we're going to put points at 1 and at 7. And we're going to try to figure out what values here are good, what values are bad, what values work, what don't. So let's try some values at each different point here. I want to try some easy values. So I'm going to try 10, I'm going to try 2, and I'm going to try 0. Obviously 2 is not directly in between 1 and 7 like I have there, but let's find out. I just want to try it. So let's do 0. 0 minus 7 is going to be negative 7. 0 minus 1 is going to be negative 1. Negative 7 over negative 1 is going to turn into just positive 7. Is positive 7 less than or equal to 0? Well, positive 7 is not, right? So that means 0 does not work. This is an interval that is not working for our equation. So let's try out our next value. 2. 2 minus 7 is going to be negative 5. And then 2 minus 1 is going to be 1. Negative 5 over 1 is negative 5. Is negative 5 less than or equal to 0? Yes, it is. So that means 2 is a value that works for us. So that's good. So this is a positive interval. We'll try our last one here, 10, right? 10 minus 7 is going to get us 3. 10 minus 1 is going to give us 9. 3 over 9, or 1/3. Is that less than 0? Of course not, because it's positive. So that is an interval that does not work. Again, much like the polynomial inequalities in my last video, we often I want to say always, but I'll be honest, polynomial rational inequalities have not always been my strongest suit. But I am very confident that we always either have, you know, the middle is good and the sides are bad, or the sides are good and the middle is bad. In this case, the middle here is the only thing that worked for us. So what we're going to be able to do is write our inequality, and we're going to be able to say our lowest value is 1, and our highest value is 7. Since we don't have a break in that domain, per se, we don't have to use a union or anything like that. And we ask ourselves, can it be 1, can it be 7? Well, it's not an or equal to, so we have to use some parentheses here. So our range, or our domain, our interval notation is going to be 1, 7. Presuming this worksheet has answers on it, yay, we got it right, 1, 7, awesome. So let's try out one other problem here. Let's do number 6. Let me try to erase everything I've got going on give me some more room. This program is kind of weird with erasing. It's not an actual eraser. If it touches the line you made, then the whole thing goes away. It's super weird, not gonna lie. Anyway, we're getting there. We got there. Nope, there's still a 9. Okay, there we go. We're going to talk about number 6. So number 6, again, we want it to be equal to 0, and we want it to be in simplest form. So is it equal to 0? Yes. Is it in simplest form? No. The numerator is, we have x plus 6, that's great, but our denominator is not because it's a polynomial, and we always want things to be written as binomials. Now again, we get to do basic factoring here. Factors of negative 24 that add up to negative 5. Well, if you think about that a little bit, I'm betting it's going to be a negative 8 and a positive 3. X minus 3, or x minus 8, x plus 3. So we have x plus 6 over x minus 8, x plus 3. This binomial doesn't exist anymore, or that polynomial doesn't really exist anymore. We're going to set all of these equal to 0. So we're going to say x plus 6 equals 0. Well, that's going to make x be negative 6, right? We're going to set this equal to 0, x minus 8. That's going to make x equal positive 8. And x plus 3 equals 0 is going to make x equal negative 3. So these are going to be our 3 points on our number line. So when we write out this number line here, we're going to have multiple different points. Ooh, that is an ugly line. Let me erase that line because that looks so awful. So bad. Okay. So I'm going to make this number line... It's a little bit better than it was. So I have negative 6, I have negative 3, and then I have 8. And what I'm going to want to do is kind of like before, I want to choose a number in each of these intervals. So I want a number that's lower than negative 6. So I'm going to choose negative 10. I want a number that's in between negative 6 and negative 3. I'm going to choose negative 5. Negative 3 and 8, I'm going to choose 0, and with 8 or above, I'm going to choose 10. So this is going to tell me which ones of these intervals work. Now, since the big difference here to our previous one is we have more than just 3 intervals. We don't have 2 sides and a middle. We kind of have 2 sides and 2 middles. It's a little weird, right? So what can happen is that kind of rule of thumb I was talking about in the last video and this one of how if the sides work, the middle doesn't, or if the middle works, the sides don't. That's no longer going to apply whenever you have more than just 2 binomials in your simplified rational equation, because right now we have 4 different parts we're trying. So let's try these out here. I'm going to start with negative 10. So if I go to my equation, negative 10 is going to be what I'm trying out. So x plus 6. Negative 10 plus 6 is going to be negative 4. Negative 10 minus 8 is going to be negative 18. And then negative 10 plus 3 is going to be negative 7. So here's the deal. I could go ahead and multiply this kind of stuff. I could multiply negative 18 times 7. I'd be like, oh my gosh, what in the world is that? I don't actually know right off the bat, right? I could grab a calculator, I could punch in, I could solve this. But what I can actually notice instead is that this is a negative 4. So we have a negative in the numerator. And this is a negative times a negative in the denominator, making it a positive. So this is a negative over a positive. So is this value going to be greater than 0, or is it going to be less than 0? And what we can see is that a negative over a positive is going to make a negative. If this is a negative, can it be greater than 0? No. So that means this interval does not work, because we got a value that was negative, and the question is asking for greater than 0. So I'm going to move on to the next one. I'm going to try out negative 5. So negative 5 plus 6, that's going to make negative 1, right? No, negative 5 plus 6 is going to make positive 1. My bad. At least I caught that, and I didn't keep doing the problem. Negative 5 minus 8 is going to make negative 13. Negative 5 plus 3 is going to make negative 2. So what's going to happen is our numerator is positive, Our denominator is two negatives multiplying, so that's positive, and a positive over a positive is going to stay a positive number, right? Is a positive number greater than or equal to 0? Yes, perfect, wonderful. This interval works. What we're going to look at next is 0. So for 0, 0 plus 6 is going to be a positive 6. 0 minus 8 is going to be a negative 8. And 0 plus 3 is going to be 3. In other words, we have a positive 6 over a negative times a positive, or ultimately a negative, right? This is two different signs. It's going to make a negative number, and a negative is not greater than or equal to 0. So this is actually going to be an interval that does not work for us. Eek. So we have one last value that we want to try out, and that is 10. In the numerator, 10 plus 6 is going to be 16. In the denominator, 10 minus 8 is going to be 2. 10 plus 3 is going to be 13. So ultimately, we have a positive 16 over two positive numbers multiplying, so that's going to make a positive. A positive over a positive, is that greater than or equal to 0? Yes, wonderful it is. Perfect. So this is an interval that does work. So what we're going to do is we are now going to write our interval notation because we have our number line and we know exactly where things do work and where they don't. So our lowest value it possibly can be is right here, starting at negative 6. Again, this has a greater than or equal to sign, so that's going to be a bracket, and this interval goes all the way up to negative 3 right here, right? Bracket that thing up. Then we have our union, and I'm going to run out of space because it doesn't let me write off this page, so I'm going to write my union down here. My next value after negative 3 is actually 8. And then 8 goes off forever, up into infinity. Can infinity have a bracket? No, it cannot. So even though we have or equal to and everything else is bracketed, this infinity is actually going to have a parentheses. So we have negative 6 to negative 3, union 8 to infinity. Let's check our work. Negative 6 to negative 3, union 8 to infinity. Perfect, wonderful, thank goodness. I didn't do anything wrong. I didn't embarrass myself. Yay. All right, so that's how we do one of these that has more than just 3 kind of sets there, right? When we have multiple binomials like this. If you have problems like 7, 8, where you have to make these equal 0, or where they're more complex than just subtracting a number to the other side, let me know and I'll make a video helping you out with those. Or if you have any other questions with this, just like I said on the the polynomial inequalities, if you have some specific questions you're struggling with, send those to me. I'll do those problems, on screen here. Or if you have any other questions with rational inequalities, if I didn't go far enough into the problems, whatever it may be, let me know. I will help you out and I will do those as well. If you ever have any other problems, just let me know. I'm more than happy to help.